There's a second type of overland flow based runoff generation mechanism, and we call it saturation excess overland flow. Sometimes simplified to just saturation overland flow. And you'll also see it referred to as Dunn or Dunnian overland flow in reference to Thomas Dunn, who extensively described this particular runoff generation mechanism in the 1970s. Within saturation excess overland flow, if we were to consider, again, a hill slope cross section going down to some channel, the idea is that it's raining, water's infiltrating through the unsaturated zone, it's encountering the groundwater table, and it's causing this groundwater table to rise. So this is the saturated zone below the groundwater table. This is the unsaturated zone. And as the groundwater table rises, it can rise to the point where it actually intersects the ground surface. And where it does, where the water table is at the ground surface, water will tend to exfiltrate and flow over the surface as saturation overland flow on this part of the hill slope down to the channel itself. So to describe this in words, this happens when the subsurface saturates and the groundwater table rises, intersecting the ground surface. So a few things to note about this particular type of overland flow. In contrast to Hortonian overland flow, we can call this saturation from below to help you remember it. It's extremely common in humid environments, places that are covered in grasslands or in forests. And this location of saturation overland flow is particularly common in convergent parts of the landscape where you've moved from up on a ridgetop down into a hollow. Perhaps you're above the local channel head in this example. So it's common in convergent downslope areas above the channel head and this zone can obviously dynamically expand and contract, and so you can have a saturated zone that is up here at this part of the hill slope if you're under a very wet condition, and then as the water table recedes over a matter of days, this zone can still be contributing saturation overland flow even when it's not even raining, in fact. It's worth noting that this runoff generation mechanism is still pretty fast. You're still going to get fairly flashy flow. It may not be as fast as Hortonian overland flow, but nevertheless, water moves much, much faster above the ground than it does in the ground. And so this is another method of getting rapid stream flow response in the channel.